All right, so we're doing 8.4, which is solving polynomials in factored form. So we're getting into the portion that is very, very important and actually is something that a lot of students struggle on. And what we're going to start with is a pretty easy section, but this is probably the most important section in concept for you to understand, because we're going to start talking about factored polynomials. We've talked about polynomials up until now. We've done multiplying polynomials, adding polynomials, and subtracting polynomials. So we're going to not be talking about multiplying and subtracting and adding now. We're going to be using them in factored form. This is what we call factored form right here. And this is what we had been foiling out before, but we're going to talk about this. So to do this, we have to talk about what the property of 0 is. If you recall, anything multiplied by 0 is 0. So for any real number a times 0 is equal to 0. Now, in the same sense, if I'm given a times b, I know that if one or the other is equal to 0, the entire thing will be equal to 0. 0 times b is 0. A times 0 is 0. So if a and b are real numbers and ab is equal to 0, then that means one or the other has to be equal to 0. So either a equals 0 or b equals 0. That's the only way to get a product to be 0. So the zero product property is used to solve an equation when one side is 0 and the other side is a product of polynomial factors. Okay, so here's what we're going to be looking at. We're looking at two factors that are going to be equal to 0. So the solutions of such an equation are also called roots. Okay, so we can call them zeros, we can call them roots. I'm going to also say these are zeros. And we can also call them x-intercepts. They can all be called the same thing. So here's what this means. When you have something that's factored and it's set equal to 0, what we're looking at is we want to know what values will make this 0. Well, we just got done saying if I can get this entire thing right here to be equal to 0, then the entire thing will be equal to 0. Same thing here. If I can get this entire factor to be equal to 0, then the entire thing is equal to 0. So what we can say is if x plus 8 is equal to 0, or if x plus 3 is equal to 0, that's going to be my solution. So we solve each one of these equations. Minus 8 on both sides, we get x equals a negative 8. Or minus 3 on both sides, we get x equals negative 3. So here's what the point is. If I know that x is equal to negative 8 plus 8 is equal to 0. 0 times anything is 0. That works. X equals negative 3. Negative 3 plus negative 3 is 0. Times anything is 0. That's why these two are both the solutions. Okay? So let's look at one more example here. So we have x minus 4 and x minus 5. So we do x minus 4 is equal to 0, or x minus 5 is equal to 0. Again, the point of this is to figure out when these are 0. So add 4, we get x equals 4. Add 5, we get x equals 5. Okay? So that's the basic idea of this. It's very, very straightforward, very simple. Okay, over here, another example. We have 2x minus 1 equals 0. We have x plus 1 equals 0. Just solve each one of these equations. Add 1, add 1. So we have 2x equals 1. Now we divide by 2, x equals 1/2. Minus 1, x equals negative 1. There's our two solutions. Again, all that means is that if we were to plug one of these in, it would make one of our factors 0, which would make the entire thing equal to 0. If it's just a term on the outside like this, then just set that equal to 0. X equals 0, done. 3x plus 1 equals 0. And then just solve. Again, it's pretty much the same process all the way through, but you need to understand the idea of this is not just going through this method and this random thing where, oh, we're just going to set it equal to 0. Understand, if I want one of these factors to be equal to 0, why do I want one of them to be equal to 0? Because I know if 1 is equal to 0, the entire thing has to be 0. Anything multiplied by 0 is equal to 0. Okay, so what I want you to do is try these two on your own. and then just go ahead and hit play when you're ready. Okay, so setting each of these equal to 0, you should have gotten x equals negative 2/3 and x equals positive 6. Over here, you should have gotten x equals 0 and x equals 1. Okay, moving on. So now what we're going to do is we're going to talk about factoring. The reason why we're going to talk about factoring is because to be able to solve for zeros, like what we did on the previous page, we have to factor first. So it says, to solve a polynomial equation using the zero product property, you may need to factor the polynomial, or write it as a product of other polynomials. Look for the greatest common factor of the polynomial's terms. This is a monomial with an integer coefficient that divides evenly in each term. So in other words, we are going to be taking polynomials that look like this, and we're going to be trying to get them to look like polynomials that either look like this or, specifically today, problems like this. Because once we get them to look like this, then we can solve for our zeros. Okay, so let's get right to it. So what we're going to do, and this is difficult for a lot of students, we're going to look for common factors, common things that go into both of them. So nothing is common between x and y, so we're just looking at our numbers. So the greatest common monomial factor that goes into both of these is just a number. What number goes into both 8 and 12? The largest number that goes into both 8 and 12 is just 4. 4 goes into 8, 4 goes into 12. So that's our first step, is just understanding what the greatest common factor that goes into that is. Okay, we're looking at b. Okay, well now we have a problem because now our y's are similar. We have the same letter, same variable. We also have numbers that are common. So the greatest number that goes into both of these numbers, 7 goes into 14 and 7 goes into 21. So part of our common factor is going to be 7. But also what we need to do is realize that y squared factors into y times y. So therefore, y is going to be our greatest common factor. The general rule of this is the common letter will always be the lowest, will be the lowest exponent variable that you have. So if we have y squared and we have y, then y has to be part of our common factor. Okay? Y squared and y are common. Take the lowest exponent number that you have. So in the next one, so our common factor there was 7y. In the next one, we look for our numbers. The greatest number that goes into both 6 and 30 is 6. 6 goes into 6 once, 6 goes into 35 times. Now when we look at our variables, the x's are common. And what we said before, the common x's will be this. It will be the lowest exponent. So our common factor there is 6x to the 5th. You take the lowest one that you have. X to the 5th does go into x to the 7th because x to the 5th times x squared is equal to x to the 7th. So if I were to rewrite this out, it would look like this. 6x to the 5th times x squared, that's this term. And the other one would be 6x to the 5th times 5. Notice what is common between those. 6x to the 5th. Very, very difficult for students to understand that at first. It will take some getting used to. You just got to try it and practice it. Okay? So what we're going to do in these examples is we want to pull out our common factors. So here's what I'm looking for here. I'm going to do one with you, and then you're going to do one on your own. So we are going to pull out our common factors. So I want you to look for what's common between our numbers and what is common about our letters. So our numbers, we have 8, 14, and 8. So you want to find what is the largest number that goes into all three of those. And from the looks of it, I think it's 2. So that means that our greatest common factor is going to be 2. And then we look at our b's. So we look for our lowest b. So it's just going to be a regular 2b. What does that mean? Well, what it means is if we have a common factor can be pulled out of each term, meaning that 2b is going to now go on the outside. And this is the most difficult part about this. If we bring a 2b to the outside, it means we're dividing by 2b on every single term. We're dividing out a 2b. We're pulling off a 2b off of each term. So in other words, 18 divided by 2 is 9. B to the third, if we pulled one of our b's off of there, then we're still left with b squared because we only pulled one off of there. The next term, 14 divided by 2 is 7. We pulled one of the b's off of our b squared, so we're left with b. Minus 8 divided by 2 is 4, and the b that was already there came to the outside, so we don't have any b's left. So the point is that when this is factored out. We just factored something out here, and what you're looking at here is if you multiply this back through, you should get what you started with. 2b times 9b squared is 18b to the third. 2b times 7b is 14b squared. 2b times negative 4 is negative 8b. Okay, so first find what the greatest common factor is, pull it to the outside, and you're basically pulling it off of each term by dividing it and then writing what's left. Okay, let's see if you can do this one on your own. So hit pause on the video and then hit play when you've had a chance to try this. Okay, so you should have first found your GCF. That's your greatest common factor is 3 because 3 is the largest number that goes into both of these. And then w squared because that was our lowest variable with an exponent. So that comes to the outside. And then what you're left with is you have 9. Why? Because 3 times 9 is 27. So you're basically looking at 3 times what equals 27? 9. Then we pulled 2 of the w's off of the w to the fourth because that came to the outside. So we're left with w to the second on the inside. And then our second term, 3 times 5 is 15. And then because the w squared was pulled off of it to the outside, we have nothing left on the inside except for the 5. Okay? So now what I want to do is let's get into exactly why we're doing this. So we're trying to solve for zeros, and the only way we can solve for zeros is by factoring. So that way it will look similar to what it did on the front side of this page. So the first thing we do is we're going to factor this by finding our GCF. So our GCF here is 3. 3 is the greatest common factor of 3 and 18. And then we take our lowest exponent variable, so it's 3x. So when we rewrite our equation, we get 3x on the outside, and we get the 3's pulled out to the outside, 3 times 1, and then we need an x. We pulled 1x off, so we're left with 1x, plus 3 times 6 is 18, and the x was already pulled to the outside, so that's all we're left with. So now that is equal to 0. So what we're going to do here is we're going to do exactly what we did on the previous page. We're going to say, okay, I need to solve. So that means that we're going to have 3x equals 0, and we're going to have x plus 6 equals 0, and then solve. Divide by 3, divide by 3. X equals 0. That's one of our solutions. Next one, minus 6, minus 6. X equals negative 6. That's our other 0. Okay? So what I want you to do is, actually, let's go through one more example here. So let's say we have a problem like this. So we have 4t squared, and then we have equals 4t. Well, if we're going to solve, we need to get it equal to 0. So to get it equal to 0, we want to bring everything to one side so it is equal to 0. So we're going to minus 14t to both sides. So that will just look like 4t squared minus 14t equals 0. And then we're just solving this equation by factoring. Greatest common factor here is going to be 2t. So we'll have 2t on the outside. We'll have 2t minus 7 on the inside. And then we're going to solve. 2t equals 0. That will be t equals 0. We have 2t minus 7 equals 0. So we have 2t equals 7. T equals 7 over 2. So there's our two solutions. Okay? So what I want you to do is do these two problems on your own for class tomorrow. I know that you may struggle with this, but we're going to have time to work on this in class, so we'll see you then.